All right, so you've got the hang of Select, right? You can grab data. But what happens when you grab, well, way too much? That's what we're tackling today. This is the next big step in your SQL journey, filtering. We're going to learn how to slice through all that noise and find the exact piece of information you're looking for. Let's jump right in.
You know, no matter what you're working with, customer info, product lists, you name it, databases are just huge. We're talking thousands, sometimes millions or even billions of rows of data. And trying to look at all of that at once, it's just a lot. It can be totally overwhelming.
So, when you're staring at this mountain of data, how in the world do you find that one thing? You know, that one specific customer you need to look up, or that single transaction that seems off. It feels impossible, right? It's the classic needle in a haystack problem.
Okay, so let's frame this a different way. I want you to think of yourself as a data detective. Seriously, the database, that's your crime scene. It's just full of clues, right? And your job is to use the right tools to sift through it all, to find the real evidence and ignore everything else. And that brings us to your number one tool, the most essential piece of kit for any data detective, the where clause. This is it. This is your magnifying glass. It's what lets you tell the database, hey, don't show me everything, show me only the stuff that matches these specific conditions. And you know what's so great about it? The syntax, it's just so intuitive. It practically reads like a normal sentence. You're literally telling it, select these columns from this table where some condition is met. It's super simple, super direct, and honestly, it's a game changer.
Okay, theory's great, but let's see this thing in action. Let's open up our first case file. We're going to be digging into this customers table. As you can see, it's got stuff like names, ages, salaries, and where they're from. Our mission? To interrogate this table and pull out some very specific people.
All right, first question for our database. Let's keep it simple. We just want to find all the customers from the USA. So we write our query. We say select everything, which means select everything, from customers where country equals USA. And here's a super important tip. Whenever you're working with text, or we call strings, you've got to wrap them in single quotes. Don't forget, and boom, just like that. The database does all the heavy lifting, scans the whole table, and hands us back just two results, Ramesh and Mukesh. Everyone else filtered out, gone. See how powerful that is? One little line of code and we slice right through the noise to get our answer. That's the where clause for it.
So that equals sign we just used, that's called a comparison operator. And it's just one of the basic tools or interrogation techniques you have in your detective bag.
So here's your main toolkit. You've got your basic equals. But you can also check if something is not equal using the exclamation point equals, and then of course you've got all your standard number comparisons. Greater than, less than, greater than or equal to, and so on. These little symbols are the building blocks for asking really specific questions.
But you know, a real detective almost never solves a case with just one clue, right? The magic happens when you start connecting the dots, when you link multiple pieces of evidence together. Well, guess what? We can do that in SQL too.
The way we do this is with something called logical operators. And the first one you've got to know is AND. AND is super straightforward. It just tells the database, hey, I need all of these conditions to be true. So it's like telling your partner, okay, the suspect has to be over 30 and they have to make less than 4,000. Both things have to check.
So this is what our query looks like now. We're selecting everything from customers, where the age is greater than 30 and the salary is less than 4,000. We're chaining our clues together.
And check out the result. We get just 3 people, Ramesh, Komal, and Hardik. Now think about what just happened behind the scenes. The database looked at every single row. It found some people who were over 30, sure, but their salary was too high, so nope. It found other people with the right salary, but they were too young. Nope. Only these 3 individuals ticked both boxes. That's how AND helps you zero in with incredible precision.
Okay, so here's the bottom line. AND makes your search narrower, more specific. Both things must be true. Now, its counterpart is OR, and it does the opposite. It makes your search broader. With OR, only one of the conditions needs to be true. That's perfect for when your clue is like, the suspect was in this location or that location. All right, but let's get real for a second. In an actual investigation or just in real-world data, you don't always have perfect information. What if your witness says, I don't remember the whole name, but I'm pretty sure it started with a K. Now what do? You don't have the full name to search for. All you've got is a partial clue.
Well, for exactly this kind of situation, our detective kit has a special tool. It's called the like operator, and it's built for pattern matching, basically for finding text when you only know part of it. It's perfect for finding something that's, well, like the clue you have.
Like has a secret weapon, wildcards. The most common one you'll use is the %sign. Think of it as a match anything character. It can stand for 0, 1, or a whole bunch of characters. Then there's the underscore, which is a bit more specific. It stands for exactly one character. Using these two, you can create some really flexible search patterns.
So let's solve our starts with K mystery. The query looks like this. We select customers where the name is like K%. That little pattern, K%, is telling the database, find me any name that starts with a capital K, and I don't care what comes after it.
And there you have it, Kaushik and Kamal. The database found them instantly. So even with a fuzzy partial clue, like let us crack the case. This is one of those tools you'll use all the time, because real-world data is almost always a little bit messy.
Okay, let's boil this all down. What's the crucial takeaway here? You've just armed yourself with a whole new set of fundamental tools for your data detective work.
So, think about your new toolkit. Where is your all-purpose magnifying glass for filtering? Your comparison operators, the equals, the greater than, those are for asking direct, pointed questions. The logical operators and or are for combining your clues to build a solid case. And like, that's your secret weapon for chasing down leads when the trail goes cold.
So now you've got the tools. You have the power to dive into those huge data sets and pull out exactly what you need. So the only real question is, what are you going to find? What mysteries are you going to solve with this? Thanks for tuning in.